So let's take our solving of our two-step equations and kind of ask ourselves, where does this get used in the real world? We're still talking about what is equivalence. We're still talking about balance. And that equal sign is making sure that both sides of the equation stay in balance. So, here's just a silly one, but let's start talking about translating words into math. So let's say you wanted to write an equation for this English sentence, which says the sum of twice a number and 6 is 26. And you'll hear I kind of paused as I went. So you kind of need to know what the words mean. So sum means what? Did you say addition? So we're going to be adding. We're going to be adding twice a number and 6. Twice a number and 6, and that has to equal 26. Can you write the equation that matches that statement? Let's see how you did. So twice a number, so sum twice a number and 6 is 26. So this is where if I used an x, not an n, that's fine. Any variable of your choosing is fine. So what we need to first do is make sure we're comfortable as to what words mean what math. So let's just take a look at a chart that I created here with keywords. Now, the first thing I kind of want to draw your attention to is the word is means equals. So we go back to over here, is 26 meant equals 26, right? So when we're looking at words like sum that we just saw, that would be addition. Obviously, plus, add, more, 3 more, greater, higher, raised, increased by, in all, total. These are all addition words. Now, subtraction, obviously the words subtract and minus, difference, less, fewer, shorter, lowered, decreased by. These words all will tie into subtraction. So for multiplication, again, obviously times and multiply, but the word product means multiplication, each. If you see like two-thirds of, the word of often means multiplication. Factors, twice a number, we just saw that one. Or squared and cubed, all of these things all of these words tie into multiplication. Division would be divided, obviously. Quotient is another one. Quotient means division. Per, rate, ratio, split something, that would mean to divide it. To separate something would be to divide. So this is kind of a little bit of a cheat sheet here, and it will be part of the notes pages for this particular video. But there are sort of the words that tie in to the different math statements. So when we look at a simple one, and we're still not out in the real world yet, we're just trying to do some translating. 8 less than 3 times a number is negative 23. So you understand that is negative 23 equals negative 23. And we know that less is minus, but this one I have to be honest, is the backwards one. And people will often write this backwards and they'll put 8 minus 3 times the number. But I want you to think about this question. What is 2 less than 20? And I'm hoping you said 18. So it's not 2 minus 20, which would be negative 18. It's 20 minus 2. So when you see less than, the minus comes behind. So it's behind the 3 times the number. Now, once we have this equation, this looks exactly like what we were doing in our last section in solving a two-step equation. And we'll get back to that in a second. Right now, we're going to focus on translating. 13 is 7 more than 1/5 of a number. So notice I just kind of stopped myself. So 13 is 7 more, and because addition is commutative, if you put the 7 plus the 1/5 n, that would be fine. I don't know why the book went this way. It doesn't matter. But so 13 is 7 more than 1/5 of a number. Remember, if we look at our chart, 1/5 of a number is multiplication. Now, we haven't talked yet about solving something with this fraction, but you could write the equation even though there's a fraction in there. So now what we need to do is just switch these to be their mathematical equivalents. So 15 equals 3 more than 6 times a number. Write that over here in math speak. Did you get 15 equals 3 more than 6 times a number? And if you put 15 equals 3 plus 6n, that is the same equation, because the commutative property of addition allows you to switch the order. Next one, 10 increased by the quotient of a number and 6 is 5. Start with the 10 and one step at a time, see if you can write that equation. So 10 increased by the quotient, which is division, of a number and 6 is 5. That one, directly translated. Now you cannot have 6 over n because division does not commute. 12 divided by 2 is not the same thing as 2 divided by 12. The difference between 12 and 2/3 of a number is 18. Try to translate that one. So 12 minus, there's the difference, the minus, 12 and 2/3 of a number is 18. And pretty soon what we are starting to see is two-step equations. Now don't get worried about this fraction. We did talk about doing these. I'm hoping we'll get a chance down the road, but we do a lot of this kind of work next year in algebra. Okay, so now let's take it a step further. Like, who cares about the quotient, like, of 2 and a number? Like, we don't do that in the real world. Where is this stuff translated to a job, to real world? And here's sort of an example. Let's say that you want to attend a 2-week robotic day camp. It could be any kind of camp. It could be a basketball camp. It could be a music camp, okay? And let's say that the camp is going to cost you $700 next summer. Your parents said, you know what, we'll pay the deposit of $400, but you need to come up with the remaining amount. And you're going to pay it to them in weekly payments. So every week you're going to give your parents $15. So you're going to be babysitting, or you're going to be doing something to earn that money to be able to pay your parents every week. You're going to use the questions below to help you find the number of weeks you will need to make payments. So we're going to complete the table below. So remember that your parents paid the $400. So when we have no payments, no time has gone by, you haven't made a payment, you have $400 that they gave you plus none of yours. You did not pay a payment yet. And 15 times 0 would be 0. So 400 plus 0 would be 400. Now, after 1 week, after one payment, you'd still have their $400 plus now you have one payment of 15. So you would have 415 heading towards that $700. Can you now fill in the next line of this chart? So after 2 payments, did you put 400 plus 2 15s? And if you do your order of operations, don't add. Remember, you multiply first. 15 times 2 would be 30. Add it to the 400, and you're $430 on your way to the 700. How about the next one? 400 plus 15 3 times would be 445. And how about the last one? So after 4 payments, you have $460. It will take a long time to solve the problem like this in filling a table. So instead, we're going to write and solve an equation to find the number of payments, and we're going to call the payments P. They define the variable for us that you will need to make. Okay, so we're going to write an equation and look at what you did up here. What's staying the same? What's varying? And let's see if we can come up with an equation to get out to the amount of money you need. Let's see how you did. So you're going to take your parents' $400 and you're going to add $15 for every payment you make, and that's your P. And what are you hoping to get in the end? How much money do you need? You need the $700. Now, I already solved it here for you, but let's remember how to solve this equation, okay? So it looks like we're going to have to make, 20 payments, but where did that come from? Let's solve this equation. So here comes our last section. We're not going to touch the 15. We're going to undo the adding first. So we're going to subtract 400 from both sides. 400 minus 400 is going to give me a 0. The 15p is going to drop down, equaling on the other side 300. Now to undo multiplying by 15, we're going to divide by 15, and there comes the 20 payments. And here's a really good example of where we would use an equation in a real-world setting. So when you're translating sentences into equation, remember that we're going to describe the situation. You're going to use only the most important words. You're going to define a variable. So you're going to get to pick your variable. In that last one, they told us P had to be the number of payments. You're going to get to pick it. And when you do, you tell us what it is and what it represents. I'll show you what that means in a second. You're going to write an equation, and then we're going to solve it. We're going to check it, and we're going to make sure we answer the question. So this is your book sort of recipe, but let me show you an even more detailed one. This is the recipe when solving a real-world problem that I give to my algebra students. So the first thing I tell them to do is what is missing? What is the question asking? You're going to pick a variable to represent that, and that's called defining a variable. Again, in the robotics one, P was the number of payments, and you're going to write that down. You're then going to write an equation that uses that variable and all the relevant information. You're going to relate the variables to the other information. You're going to translate the words to operations like we've been practicing. You're then going to flip back basically to what we did in this last section, which was to solve the two-step equation. You're going to check your solution, and then you're just going to make sure that you're answering the right question. You're going to put your units in. You're going to make sure that your answer answers the question asked. And this really becomes important down the road when there's possibly more than one question that could be asked. So let me show you those 5 things on page 131, example 3. You're going to see 1, 2, 3, 4, and 5. I'm typing those in. Those aren't in your books to show you sort of the 5 things we need to do. So the first thing we're going to do is we're going to read this problem carefully. You buy 3 books that each cost the same amount. 3 books, they're all the same amount. Maybe they're $5 a piece. Maybe they're $8 a piece. Maybe they're $4.99 a piece, okay? And you're also going to buy 1 magazine. And your total when you check out is $55.99. Now, you know that the magazine was $1.99, but now you're trying to remember kind of after the fact, you're sitting in the car, what did each book cost? Now read that question. How much does each book cost? That is our unknown. That's what our variable is going to represent. And look right here, the book saying, let B represent the cost of 1 book. Now I'm okay if you came over here and said B equals, and then in words, the cost of 1 book. And you'll see me do that in an example in class. But you tell me what your variable is and what it represents in the problem. That's called defining the variable. And now we're going to write an equation. Now remember, we bought 3 books. So 3 books at some cost that we can't remember, plus the 1 magazine that we know is $1.99, and our total is $55.99. So here's the equation that I need to solve. So 1, what's our variable? What does it represent? 2, write an equation using the numbers in the problem. Now we're going to do our 2-step equation. We're going to subtract $1.99 for both sides. We're not going to touch the 3. That's the no-fly zone there. And once we get that, we have 3b on the left because this is a 0 and 54 on the right. To undo multiplying, we divide by 3 and we get b equals 18. we've solved our equation and we've shown the appropriate steps. So the next thing we're going to do is we're going to check it, which your book fails to do. So I'd like you to write this in, please. We're going to go back to this equation and we're going to take out the b and put in the 18, and does the math work? And you're literally going to pick up your calculator and you're going to take 3 times 18 and hit equals, and it says 54. I'm going to write that down, plus 199. Does it equal 55.99? And in my calculator, I add the 199. I'm seeing that it does equal 55.99. So this 18 is the right answer. But what 18 what? 18 Doritos, 18 elephants, 18 what? No, 18 is the cost of the book. So it should be $18. So let's do one more here. A personal trainer buys a weight bench for $500 and he's going to call it W weights. And each weight that this person is buying is $24.99. The total purchase at the register, let's say we're at Dick's Sporting Goods, is $849.86. How many weights were purchased? That's our unknown. That's the variable. And they told us to use W. So, W represents the number of weights, not the cost. They told us the cost, but how many did we buy? So we bought one weight bench for $500 plus some number of weights that were $24.99. And remember that number should go in front of the variable. It's called the coefficient. It goes in front. So here's the cost for the weight bench. And this 24.99 times W is the cost of some number of weights. And when we add those together, we paid a total of $849.86. Bench plus weights equals the total cost. So now I'm going to solve it. I'm going to subtract 500 from both sides. You're not going to touch that coefficient. We're going to wait. We're going to undo the adding first. I still have the $24.99 W, and over here it's now $349.86. That was my total cost for the weights, but how many weights? Take that amount of money and divide it by the $24.99, and we're using our calculator, and we get 14. I'm going to check it. Again, the book failed here, and I'm going to put 14 in. I'm going to multiply before I add. Don't go left to right. PEMDAS, do your multiplying first. Whoop, whoop, whoop. And when I multiply, I'm going to get 349.86. And when I add it to the 500, sure enough, the total works. But 14 what? Remember that 14 was the number of weights. So my answer to the question is that 14 weights were purchased. And that is how we do real world examples with our equations. So we have one more example here that I'm going to ask you to pause the video, and the Edpuzzle should do it for you. And I want you to define a variable. I want you to write an equation and solve it. I want you to check it, and I want you to answer the question. So pause the video and try to do this one yourself after I finish reading it. The current temperature is 54 degrees Fahrenheit. It's expected to rise by 2.5 degrees Fahrenheit each hour. How many hours will the temperature be 84 degrees? How many hours later? Pause the video, define your variable, write your equation, solve it, check it, answer the question, and let's see how you did. Okay, so now you don't have to have the same variable as me, but it should represent the number of hours. So you could have used N, Q, whatever. I used H is the number of hours. Now we start at 54 and we're going to go up 2.5 degrees every hour. So that 2.5 is varying. And we're wondering, when will it equal 84 degrees? This is your equation. If you didn't do that equation, you'll have the wrong answer. Okay, but did you show the right steps? So can you please fix this one if you did it incorrectly? I'm not going to touch the 2.5, the coefficient on the H, but I am going to undo the adding. So I'm going to subtract 54 from both sides. And now I'm going to pick up my calculator. The opposite of multiplying is to divide. So I'm going to divide both sides by 2.5, and 30 divided by 2.5 is 12. I'm going to check that 12 by replacing the H like I did in the last section. I'm going to multiply before I add. Jump over. Don't forget, you multiply before you add. And then I'm going to add, and I'm really happy right now because 12 is the right answer. But 12 what? 12 leaves? 12 dogs? What is it? No, it's 12 hours. That's what that means. So it will take 12 hours for the temperature to be 84 degrees. Guys, you're doing algebra and you're taking your equations and you are putting them into the real world. This is where we use this stuff. So we're now going to have a chance to practice. After we do a reteach, when you come into class, we'll do some together, and then you'll get a chance to do some more on your own. Guys, I hope you have a great day.